Kafka real-world example for full-stack developers. Introduction. Apache Kafka is a distributed event streaming platform used to publish, store, process, and consume events at scale. Full-stack developers often learn Kafka to build. Check event-driven applications. Check microservices communication. Check real-time notifications. Check order processing systems. Check audit logging systems. Check activity feeds. Check analytics pipelines. Check asynchronous workflows. Check cloud-native applications. A common learning topic is, how can full-stack developers use Kafka in a real-world application? This guide explains. Check. Kafka basics, real-world use case, front-end, back-end flow, producers, consumers, topics, partitions, consumer groups, Spring Boot implementation, React integration, PostgreSQL integration, retry handling, dead letter topics, monitoring, testing, best practices, interview questions. Kafka's official documentation describes Kafka as a distributed system made of servers and clients that communicate using a high-performance network protocol. In Kafka, producers write events to topics, and consumers read events from topics. Topics can be partitioned for parallel processing and replicated for fault tolerance. Simple definition. Kafka is a message event platform that helps services communicate asynchronously. Simple idea. Something happens in one service. Service publishes event to Kafka. Other services consume the event. Each service reacts independently. Example. User places order. Order service publishes order created event. Payment service consumes event. Inventory service consumes event. Notification service consumes event. Full-stack developers learn Kafka because modern applications often need, sure, async processing, sure, real-time updates, event-driven workflows, decoupled microservices, sure, scalable background processing, sure, reliable message delivery, sure, activity tracking, analytics events, notification pipelines. Full-stack developers already understand current user actions, current REST APIs, current backend services, current databases, current authentication. Kafka connects user actions to backend event processing. Real-world use case, e-commerce order processing system. Scenario. A user places an order from a React frontend. The backend creates the order. Kafka publishes an order-created event. Multiple services react to that event. Services. Coq, React frontend. Coq, Spring Boot order service. Coq, Spring Boot payment service. Coq, Spring Boot inventory service. Coq, Spring Boot notification service. Coq, architecture. React frontend. Spring Boot order API. PostgreSQL. Kafka topic, order created. Payment consumer. Inventory consumer. Notification consumer. Problem without Kafka. Without Kafka. Order service calls, payment service calls, inventory service calls, notification service returns response to frontend. Problems. X, frontend waits too long. X, one service failure can break order flow. X, services are tightly coupled. X, retry handling is harder. X, scaling is harder. X, background processing is mixed with request flow. Example. Notification service is down. Order creation fails or becomes slow. Solution with Kafka. With Kafka, order service creates order. Order service publishes order created event. Frontend gets quick response, payment, inventory, notification process asynchronously. Benefits. Check. Faster user response. Services are loosely coupled. Circ. Failures can be retried. Circ. Consumers can scale independently. Circ. New services can consume same event later. Circ. Better event history. Better cloud-native design. Kafka architecture overview. Producer. Kafka topic. Consumer group. Consumer. Real-world example. Order service producer. Order created topic. Order payment service group. Inventory service group. Notification service group. Spring Kafka provides Kafka template for sending messages. and @Kafka Listener for consuming messages in Spring applications. Core Kafka concepts. Concept meaning: producer sends events to Kafka. Consumer reads events from Kafka. Topic: named event stream. Partition: topic split for parallelism. Offset: message position. Consumer group: group of consumers sharing work. Broker: Kafka server. Key: determines partition routing. Something happened. Step 1. Understand topic. A topic is a named stream of events. Example topics: order created topic, payment completed topic, payment failed topic, inventory reserve topic, notification events topic. Simple idea. Topic equals category of events. Example: all order created events go to order created topic. Step 2. Understand producer. Producer is the application that sends events to Kafka. Example: order service creates an order. Order service produces order created event. Producer responsibility: create event, serialize event, publish to correct topic, use event key, log correlation ID, handle publish failure. Step 3. Understand consumer. Consumer is the application that reads events from Kafka. Example: payment service consumes order created event. Payment service processes payment. Consumer responsibility: check, read event. Check, validate event. Check, process business logic. Check, handle duplicate messages. Check, handle errors. Check, retry safely. Log processing result. Step 4. Understand consumer group. Consumer group is a group of consumers that share work for a topic. Example: payment service group. If topic has 3 partitions and payment service has 3 consumers. Consumer 1 means partition 0. Consumer 2 means partition 1. Consumer 3 means partition 2. Kafka uses consumer groups to distribute partitions across consumers and rebalance assignments when consumers join or leave. Step 5. Understand partitions. Partitions allow Kafka to scale. Example: order created topic. Partition 0, partition 1, partition 2. Why partitions matter? Check, parallel processing. Check, better throughput. Check, scalability. Ordering per partition. Important rule: messages with the same key go to the same partition. Example: key equals order ID. This keeps events for the same order ordered. Confluence Kafka docs explain that topics are partitioned for parallel processing and replicated across brokers for fault tolerance. Step 6. Understand offset. Offset is the position of a message inside a partition. Example: partition 0. Offset 0 means order created ORD 101. Offset 1 means order created ORD 102. Offset 2 means order created ORD 103. Consumer stores offset to know: what message did I already process? Step 7. Real-world event flow. 1. User clicks, place order. 2. React calls post API orders. 3. Order service validates request. 4. Order service saves order in PostgreSQL. Order service publishes order created event to Kafka 6. Payment service consumes event 7. Inventory service consumes event 8. Notification service consumes event 9. Order status is updated 10. Front end shows order status step 8. Event example: event ID EVT 1001. Event type order created. Event version 1. Correlation ID core ABC 123. Order ID ORD 101. User ID USR 501. Amount $149.99. Currency CAD. Created at 2026-06-06 T1000Z. Important fields. Check. Event ID. Event type. Event version. Correlation ID. Order ID. User ID. Amount. Timestamp. Step 9. Front-end flow. React front-end. User fills checkout form. Clicks place order. Post API orders. receives order ID and status created. Dot shows order is being processed. Polls or listens for status update. Front-end response. Order ID, ORD 101, status, created. Message, order is being processed. Important UX idea. Kafka processing is asynchronous. Front-end should not expect everything to complete immediately. Step 10. Backend order API. Request. Post, API, orders. Request body. User ID, USR 501, items, product ID, P100, quantity, 2. Payment method ID, PM123. Order ID, ORD 101. Status, created. Step 11. Spring Boot Kafka dependency. Maven. Dependency. Group ID, org.springframework.kafka. Group ID. Artifact ID, Spring Kafka. Artifact ID. Gradle. Implementation. Org springframework.kafka. Spring Kafka. Step 12. Kafka configuration. Application.yaml. Spring, Kafka, Bootstrap servers, localhost 9092. Producer. Key serializer, org apache kafka.common.serialization.string serializer. Value serializer, org.springframework.kafka.support.serializer.json serializer. Consumer. Group ID, order service group auto offset reset, earliest. Key deserializer, org apache kafka.common.serialization, string deserializer. Value deserializer, org springframework.kafka.support.serializer.json deserializer. Properties. Spring json.trusted.packages. com.example.events. Step 13. Create order event. Class, public class, order created event. Private string event ID. Private string event type. Private integer event version. Private string correlation ID. Private string order ID. Private string user ID. Private big decimal amount. Private string currency. Private instant created at. Public order created event. Slash getters and setters. Step 14. Create Kafka producer at service. Public class order event producer. Private, static, final, string topic equals order created topic. Private, final Kafka template, string, order created event, Kafka template. Public order event producer, Kafka template string order created event Kafka template. This Kafka template equals Kafka template. Public void, publish order created event, event, Kafka template, dot send, topic, event get order ID, event. Why use order ID as key? All events for the same order go to the same partition. This helps maintain order level event ordering. Step 15. Create order service. At service, public class, order service. Private final order repository, order repository. Private final order event producer, event producer. Public order service. Order repository, order repository, order event producer, event producer. This order repository equals order repository. This event producer equals event producer. Transactional, public order response, create order request, request. Order equals new order. Order.setUserID, request.userID. Order.setAmount, request.amount. Order.setStatus, order status created. Order saved order equals order repository.save, order. Order created event. Event equals new order created event. Event.setEventID, UUID random UUID to string. Event.setEventType order created. Event.setEvent version 1. Event.setCorrelationID request correlation ID. Event.setOrderID saved order.getID to string. Event.setUserID saved order.getUserID. Event.setAmount saved order.getAmount. Event.setCurrency CAD. Event.setCreatedAt instant now. Event producer publish order created event. Return new order response. Saved order.getID.toString. Saved order.getStatus.name. Important production note. This simple version is good for learning. For production, use transactional outbox to avoid losing events. Step 16. Create payment consumer. At component public class payment consumer. Private final payment service payment service. Public payment consumer payment service payment service. This payment service equals payment service. At Kafka listener. Topics equals order created topic. Group ID equals payment service group. Public void consume. Order created event event. Payment service. Dot process payment event. This means payment service listens to order created topic. When order created event arrives, it processes payment. Step 17. Create inventory consumer. At component, public class inventory consumer. Private final inventory service inventory service. Public inventory consumer. Inventory service inventory service. This inventory service equals inventory service. At Kafka listener, topics equals order created topic. Group ID equals inventory service group. Public void consume. Order created event event. Inventory service dot reserve inventory event. Important. Payment service and inventory service use different consumer groups, so both receive the same order created event. If they use the same group, only one service would process each message. Step 18. Create notification consumer at component. Public class notification consumer. Private final notification service notification service. Public notification consumer. Notification service notification service. This dot notification service equals notification service. At Kafka listener, topics of order created topic. Group ID of notification service group. Public void consume. Order created event event. Notification service dot send order created email event. This service can send tick email, tick SMS, tick push notification, tick in-app notification. Step 19. Payment completed event. After payment succeeds. Event ID, EVT 2001. Event type, payment completed. Event version 1. Correlation ID, core ABC 123. Order ID, ORD 101. Payment ID, pay 9001. Amount, 149.99. Paid at 2026-06-06 T1001Z. Payment service publishes. Payment completed topic. Order service consumes. Payment completed topic. Then updates order status. Created means paid. Step 20. Order status flow created. Payment processing. Paid. Inventory reserved. Confirmed. Shipped. Failure flow. Created. Payment failed. Or paid. Inventory failed. Refund requested. Cancelled. Step 21. Front-end order status page. React front-end can show order status, processing, then call. Get API orders, ORD 101. Response. Message ORD ID, ORD 101. Front-end options. Check. Polling. WebSocket. Server sent events. Notification refresh. Manual refresh. Simple polling example. Every 5 seconds, call order status API. Stop when status is final. Step 22. Kafka with WebSocket updates. Advanced architecture. Kafka event. D. Notification service. D. WebSocket. D. React frontend. Example. Payment completed event. Order status updated. WebSocket sends update to user. Front end shows payment completed. Useful for check. Live order tracking. Delivery status. Chat notifications. Dashboard updates. Admin monitoring. Step 23. Idempotency. Kafka consumers may process the same event more than once. Problem. Payment consumer receives order created event twice. Payment is charged twice. Solution. Store processed event ID. If event ID already processed, ignore it. Example. Transactional, public void, process payment, order created event, event. If processed event repository exists by event ID, event.get event ID. Payment repository save. Create payment event. Processed event repository save. New processed event. Event get event ID. Instant.now. Key idea. Consumers must be idempotent. Step 24. Retry handling. Consumer may fail because check. Database timeout, check. External payment API down, check. Network error, check. Temporary service failure, check. Validation issue.
Retry strategy.
Try processing, down. If temporary failure, retry. If still failing, send to dead letter topic. Best practices. Check. Retry transient failures. Do not retry bad data forever. Use backoff. Check. Limit retry attempts. Alert when dead letter topic grows. Step 25. Dead letter topic. Dead letter topic stores failed events. Example. Order created topic. Dash failure. Order created retry topic. Failure. Order created DLT. DLT means dot. Dead letter topic. Use it for bad event payload, repeated consumer failure, manual investigation, reprocessing later, alerting. Step 26. Transactional outbox pattern. Problem. Order saved in database. App crashes before publishing Kafka event. Order exists, but no other service knows about it. Solution. Save order and outbox event in same database transaction. A background publisher reads outbox and publishes to Kafka. Architecture. Order service, save order, plus outbox event. Outbox publisher, Kafka. This is one of the most important Kafka production patterns. Step 27. Outbox table. Create table outbox events. ID UUID primary key. Aggregate type varchar 100. Aggregate ID varchar 100. Event type varchar 100. Payload text. Status varchar 50. Created at timestamp. Published at timestamp. Example row. Aggregate type equals order. Aggregate ID equals ORD-101. Event type equals order created. Status equals new. Step 28. Monitoring Kafka. Monitor. Ology. Topic throughput. Consumer lag. Failed messages. Retry topic size. Dead letter topic size. Broker health. Partition count. Consumer group status. Producer errors. Processing latency. Important metric. Consumer lag. Consumer lag means how far behind the consumer is from the latest message. If lag keeps growing, consumers are slower than producers. Step 29. Full stack debugging flow. User says, I placed an order, but it is stuck in processing. Debug flow. 1. Check front-end network request. 2. Check post/API/orders response. 3. Check order service logs. 4. Check order row in PostgreSQL. 5. Check Kafka order created topic. 6. Check payment service consumer logs. 7. Check consumer lag. 8. Check retry dead letter topic. 9. Check payment API response. 10. Check order status update. This connects. Frontend means API, means database, means Kafka, means consumer, means database, means frontend. Step 30. Docker Compose local setup. Example services. Services. Kafka. Image Apache Kafka latest. Ports. 9092, 9092. Postgres. Image. Postgres 16. Environment. PostgreSDB. Orders. Postgres user. App. Postgres password. App. Ports. 5432, 5432. Order service. Build. Order service depends on Kafka, Postgres. Ports. 8080, 8080. Payment service. Build. Payment service. Depends on Kafka, Postgres. Local learning flow. Run Docker Compose, create order from frontend Postman. Watch Kafka event. Check consumer logs. Check database status. Real-world architecture. E-commerce, Kafka architecture. React frontend. API gateway. Order service. PostgreSQL order DB. Kafka order created topic. Payment service. Inventory service. Notification service. Analytics service. PostgreSQL. Redis. Email provider. Data lake. Real-world user journey. Place order flow. 1. User adds products to cart. 2. User clicks checkout. 3. React sends order request. Order service creates order 5. Kafka receives order created event 6. Payment service processes payment 7. Inventory service reserves stock 8. Notification service sends email 9. Analytics service records event 10. User sees order confirmed. Kafka topic design. Recommended topics. Order created topic. Payment completed topic. Payment failed topic. Inventory reserved topic. Inventory failed topic. Notification sent topic. Avoid 1 generic topic. Events topic. Better. Use clear topic names based on business events. Kafka key design. Use keys carefully. Examples. Event key. Order created, order ID. Payment completed, order ID. User registered, user ID. Product updated, product ID. Why? Same key goes to same partition. This preserves ordering for that business entity. Kafka consumer group design. Example. Payment service group, inventory service group, notification service group, analytics service group. Each group gets its own copy of the event stream. If you scale payment service to 3 instances. Payment service group. Capital. Payment instance 1, payment instance 2, payment instance 3. Kafka distributes partitions among instances. Kafka versus REST in this example. REST is used for front-end means order API, front-end means order status API. Kafka is used for order service means payment service. Order service means inventory service. Order service means notification service. Simple rule. Use REST when user needs immediate response. Use Kafka when background services can react asynchronously. Kafka versus RabbitMQ in this example. Kafka is good when multiple services need same event. Event replay is useful. High throughput event stream is needed. Analytics may consume events later. Event history matters. RabbitMQ is good when C. Task queue processing is needed. Complex routing is needed. One worker should process one task. Retry DLQ workflows are queue-based. Common beginner mistakes. 1. Expecting Kafka to behave like REST. Bad thinking. Front-end waits until all Kafka consumers finish. Better. Front-end gets quick response. Consumers process in background. Front-end checks status later. 2. No item potency. Bad. Same event processed twice creates duplicate payment. Better. Store processed event IDs. 3. No dead letter topic. Bad. Failed messages retry forever or disappear. Better. Retry limited times. Then send to DLT. 4. Using random event names. Bad. Data topic, message topic, process topic. Better. Order created topic, payment completed topic, inventory reserved topic. 5. Publishing database entity directly. Bad. Publish full order entity. Better. Publish stable order created event DTO. 6. No correlation ID. Without correlation ID, debugging is difficult. Use correlation ID in API logs and Kafka events. 7. Ignoring consumer lag. If consumer lag grows, processing is falling behind. Monitor lag continuously. 8. No outbox pattern. Without outbox, database save and Kafka publish can become inconsistent. Best practices. Use clear event names. Use topic names based on business events. Use event DTOs, not entities. Include event ID. Include event version. Include correlation ID. Include a code at timestamp. Use meaningful message keys. Make consumers idempotent. Use retry and DLT strategy. Monitor consumer lag. Transactional outbox for production. Keep event payloads stable. Version event schemas. Avoid sensitive data in events. Secure Kafka credentials. Log with correlation ID. Test producers and consumers. Use test containers for integration tests. Testing strategy. Test. Correct. Producer publishes correct event. Consumer processes event. Duplicate event is ignored. Invalid event goes to DLT. Payment completed updates order status. Consumer handles retry. Event contains correlation ID. Schema compatibility is maintained. Useful tools. Check. JUnit 5. Check. Spring Boot test. Check. Spring Kafka test. Check. Test containers Kafka. Check. Awaitility. Check. Wiremock. Example integration test idea. Given order request. When order service creates order, then order created event is published to Kafka. And payment consumer processes event, and payment record is created. Kafka monitoring dashboard. Dashboard panels. Check. Messages in per second. Check. Messages out per second. Consumer lag by group. Check. Topic throughput. Check. Partition count. Check. Failed consumer count. Check. DLT event count. Check. Processing latency. Check. Broker health. Disk usage. Important alerts. Consumer lag too high. DLT messages greater than 0. Producer errors increasing. Consumer group inactive. Broker down. Topic under replicated partitions. Full stack project. Kafka order tracking system. Build. React order UI. Spring Boot order service. Spring Boot payment service. Spring Boot notification service. Kafka, PostgreSQL, Docker Compose. Features. Create order, C. Publish order created event, C. Process payment, C. Publish payment completed event, C. Update order status, send notification, C. Show status in React, C. Monitor Kafka topics. Kafka roadmap for full stack developers, beginner level. Learn. Kafka topic. Producer. Consumer group. Spring Kafka. JSON events. Build. Order created, producer and consumer, intermediate level. Learn. Partitions, keys, offsets, retries, dead letter topic, idempotency, monitoring. Build. Order plus payment, event flow, advanced level. Learn. Kafka transactional outbox. Kafka schema versioning. Kafka consumer lag scaling. Kafka streams basics. Kafka event replay. Kafka distributed tracing. Build. Production ready e-commerce event platform. 30-day learning plan. Week 1. Kafka basics. Learn. Kafka topic. Partition. Producer. Consumer group. Offset. Practice. Create simple producer and consumer. Week 2. Spring Boot Kafka. Learn. Kafka template. @Kafka listener. JSON serialization. Application.yaml config. Event DTOs. Practice. Build order created event flow. Week 3. Real world workflow. Learn. Check. Payment consumer. Check. Inventory consumer. Notification consumer. Check. Order status update. Check. Front-end polling. Practice. Build full order processing flow. Week 4. Production readiness. Learn. Check. Item potency. Check. Retries. DLT. Transactional outbox. Consumer lag monitoring. Correlation ID. Practice. Make Kafka order system production ready. Kafka interview questions. 1. What is Kafka? Kafka is a distributed event streaming platform used to publish, store, process, and consume events. 2. What is a Kafka topic? A topic is a named stream of events. 3. What is a producer? A producer is an application that writes events to Kafka topics. 4. What is a consumer? A consumer is an application that reads events from Kafka topics. 5. What is a consumer group? A consumer group is a set of consumers that share work for a topic. 6. What is a partition? A partition is a split of a topic that allows parallel processing and scalability. 7. What is an offset? An offset is the position of a message inside a partition. 8. Why use order ID as Kafka key? Using order ID as key keeps events for the same order in the same partition, preserving order for that order. 9. What is consumer lag? Consumer lag means how far behind the consumer is from the latest messages. 10. What is a dead letter topic? A dead letter topic stores events that failed processing after retries. 11. What is idempotency in Kafka consumers? Idempotency means processing the same event multiple times safely without duplicate side effects. 12. What is transactional outbox? Transactional outbox saves business data and event data in the same database transaction, then publishes events to Kafka later. Final summary. Kafka is very useful for real-world full-stack and cloud-native applications. Important concepts include topics, check. Producers, check. Consumers, check. Offsets, consumer groups, check. Spring Boot Kafka, event-driven architecture, order processing, retries, dead letter topics, idempotency, transactional outbox, consumer lag monitoring, front-end status updates. Full-stack developers already understand front-end user actions, back-end APIs, databases, services, authentication, user experience. Kafka helps connect these layers through reliable asynchronous events. Key idea: Kafka allows full-stack developers to build scalable event-driven systems where back-end services react to business events without blocking the user experience.